Something from another star system just passed through our cosmic neighborhood, and what it left behind has scientists at NASA and ESA completely stunned. A visitor that traveled billions of years across the galaxy is releasing water, and not just any water, alien water, and nobody fully understands where it is coming from. This is the story of 3I Atlas, the third confirmed interstellar object ever detected by human beings, and the first one to reveal its secrets in such breathtaking detail. What scientists discovered when they studied it closely has opened a window into a planetary system that may no longer even exist. A window that is forcing astronomers to rethink everything they thought they knew about how water, and perhaps life itself, spreads across the universe. On July 1st, 2025, a telescope in Rio Hurtado, Chile, part of the NASA-funded ATLAS survey system, caught a faint moving speck in the darkness of space. The ATLAS system, which stands for Asteroid Terrestrial Impact Last Alert System, was designed to hunt for near-Earth objects that could threaten our planet. On this particular night, it found something far more extraordinary. The object was moving at roughly 137,000 miles per hour relative to the Sun, which is already fast, but that alone was not what made it remarkable. What made it remarkable was its trajectory. When astronomers traced its path backward through the solar system, the math was unmistakable. This object had not come from anywhere within our solar system. It had come from somewhere else entirely, from outside, from interstellar space, from another star. It was given the name 3I Atlas. The number 3 because it was the third confirmed interstellar object ever found passing through our solar system. The letter I for interstellar, and Atlas for the telescope that found it. Pre-discovery images pulled from telescope archives show the object had actually been crossing through space near our solar system since at least June 14th, 2025, more than 2 weeks before anyone noticed it. But once astronomers knew what they were looking at, the scientific world mobilized with a speed and intensity that is rarely seen outside of emergencies. Every major telescope on Earth and in orbit was turned toward 3I Atlas. Hubble looked at it. The James Webb Space Telescope examined it. NASA's Swift Observatory observed it. SphereX, TESS, the Subaru Telescope, the Gemini Observatory, the Psyche spacecraft, the Lucy spacecraft, and the Punch mission all captured data. And then there was JUICE, the European Space Agency's Jupiter Icy Moons Explorer spacecraft, which was already traveling through the inner solar system on its way to Jupiter when 3I Atlas made its closest pass to the Sun. Mission operators at ESA made a bold decision. They fired up 5 of JUICE's scientific instruments and pointed them at the comet. The observation windows were tight, the signals were faint, and the thermal environment was harsh on JUICE's sensitive equipment. But they did it anyway, because they knew they were witnessing something that may never be seen again in any of their lifetimes. The data from JUICE did not reach Earth immediately. Because of the challenging conditions during its passage through the inner solar system, JUICE had to use its high-gain antenna as a heat shield, which meant the comet data had to wait. Scientists waited months. Finally, in February 2026, the data arrived, and what it showed left the team speechless. JUICE's instruments had detected water vapor and carbon dioxide pouring off 3I Atlas in extraordinary quantities. Team member Giuseppe Piccioni of the National Institute for Astrophysics confirmed that repeated detections of water vapor and carbon dioxide showed that volatile ices buried beneath the comet's surface were actively being released into space shortly after its closest pass to the Sun. Pasquale Palumbo, INAF researcher and principal investigator of Janus, the camera aboard JUICE, said his team had waited a long time for the data, but that it was truly worth it. The images, he said, revealed for the first time the comet's intense activity right around its closest approach to the Sun, showing an extended coma, a tail, and distinct structural features including rays, jets, and filaments. The scale of water being released was almost impossible to grasp. ESA reported in April 2026 that 3I Atlas was ejecting approximately 2 metric tons of water vapor every single second. That is equivalent to filling 70 Olympic-sized swimming pools with water and releasing all of it into space every single day. And the release was not just massive in scale, it was also directional. Most of that water vapor was being emitted specifically toward the Sun, which added another layer of strangeness to what scientists were already observing. But the truly bizarre discovery came from a team at the Shanghai Astronomical Observatory, part of China's Academy of Sciences, which used the ALMA Telescope to conduct high-sensitivity radio observations of 3I Atlas. What they found shattered a fundamental assumption. In our own solar system, when a comet releases water, that water comes primarily from the nucleus, the frozen core of the comet itself. Sunlight heats the surface of the nucleus and causes the ice there to sublimate, turning directly from solid into gas and streaming outward into space. That is the standard model. That is how solar system comets behave. L water being released by 3I Atlas before it reached perihelion was not coming from the nucleus at all. It was coming from icy grains scattered throughout the comet's coma, the vast halo of gas and dust surrounding the nucleus. Those icy particles, already separated from the nucleus and floating freely in the coma, were themselves sublimating and releasing water continuously as they heated up in the sunlight. The nucleus was doing its part, but the coma itself had essentially become an extended source of water production on a massive and unprecedented scale. This discovery was significant far beyond the technical details. It suggested that 3I Atlas has an extremely fragile internal structure, one that allows small, easily vaporized chunks of ice to escape from the nucleus and drift outward into the coma, while still carrying enormous amounts of frozen volatile material. It suggested a comet that formed under conditions very different from the conditions that produced comets in our own solar system. And it raised questions that scientists are still working to answer about what exactly those conditions were. The water that scientists detected first was not actually water itself. It was hydroxyl, which is the chemical symbol OH, a molecule made of one oxygen atom and one hydrogen atom. When a water molecule breaks apart under exposure to ultraviolet light from the sun, it splits into a hydrogen atom and a hydroxyl molecule. Astronomers detect hydroxyl because it emits a characteristic glow in ultraviolet light, and that glow tells them that water was there moments before. Dennis Bodowitz, a physicist at Auburn University who led the water detection research using NASA's Swift Observatory, described the discovery in terms that captured its cosmic weight. He said that when scientists detect water, or even its faint ultraviolet echo of hydroxyl, from an interstellar comet, they are reading a note from another planetary system. That is not a metaphor, it is a precise description of what happened. What made the water detection especially remarkable was the distance at which it occurred. Swift first detected hydroxyl from 3I Atlas when the comet was nearly 3 times farther from the sun than Earth is. That is far outside the zone where solar system comets typically begin losing water. In most comets from our own solar system, water sublimation only really kicks in within about 2 astronomical units from the sun. But 3I Atlas was already bleeding water at 40 kilograms per second when it was nearly 3 astronomical units away. Scientists compared this to a fire hydrant running at maximum power. The implication was that this comet has a structure far more fragile and far more volatile rich than typical solar system comets, one that begins releasing its icy contents at far greater distances from solar heat than anything we have seen before. The age of 3I Atlas adds another dimension of wonder to the entire story. Based on its chemistry and trajectory, astronomers believe this comet may be nearly 12 billion years old. To put that in perspective, our entire solar system is only 4.5 billion years old. The sun itself is a middle-aged star. But 3I Atlas may have formed around a star that existed when the universe was young, possibly around a star system that no longer exists at all. The planetary system that created this comet may have been destroyed billions of years ago, its star long dead, its planets scattered or consumed, and yet this small fragment of ice and dust kept traveling, kept moving through interstellar space, carrying within it a frozen chemical record of conditions that existed in the early universe, waiting until it crossed paths with our solar system, our telescopes, and our scientific curiosity. The compositional chemistry of 3I Atlas reveals a history shaped by cold and time. The comet contains carbon monoxide at levels roughly 28% relative to water, which is considerably higher than most solar system comets at similar distances from the sun. This elevated carbon monoxide abundance suggests the comet formed in a planetary system that was colder than ours, an environment where highly volatile materials were preserved rather than cooked away. The reddish color of 3I Atlas, which is similar to D-type asteroids and to the previous interstellar comet 2I Borisov, is consistent with the presence of irradiated organic compounds called tholins in the coma, further reinforcing the picture of a comet shaped by billions of years of exposure to cosmic radiation in the cold of interstellar space. The implications of the water discovery stretch far beyond the science of comets. For decades, one of the central questions in astrobiology, the study of life beyond Earth, has been where water comes from. Water is not just a liquid we drink and swim in. It is the medium in which chemistry becomes biology. Every living organism that scientists have ever studied, without a single exception, requires liquid water to exist. The search for life in the universe is, in many fundamental ways, a search for water. And for a long time, scientists believed that each planetary system's water supply was largely a local product, formed during the chaotic early period of planetary formation, and delivered to rocky worlds through bombardment by local icy bodies. But 3I Atlas challenges that comfortable local picture. If an interstellar comet carrying water from another star system can pass through our solar system, then water, and potentially the organic chemistry that accompanies it, can travel between star systems. It can cross the void It can see distant worlds with the raw materials of life carried from planetary systems far away and long gone. The chemistry detected inside 3I Atlas goes beyond water. The Subaru telescope observed the comet in January 2026, more than 2 months after its closest approach to the Sun, and measured the ratio of carbon dioxide to water in the coma. The measurements showed that this ratio was lower than what space telescopes had measured earlier in the mission, suggesting that as the comet heated up and different layers of its nucleus became exposed, its composition was actively changing. The interior of the comet had a different mixture of chemicals than its outer surface, which is exactly what you would expect from a body that spent billions of years in the deep cold of interstellar space, slowly transformed by cosmic radiation layer by layer. Studies using the ALMA Telescope also revealed that 3I Atlas was unusually rich in methanol, an organic compound that plays a role in the chemistry of life as we understand it. The presence of methanol, carbon monoxide, water vapor, and carbon dioxide together in a single interstellar visitor paints a picture of a chemically complex ancient body carrying an inventory of molecules that astrobiologists find profoundly interesting. There have only been 3 confirmed interstellar objects observed passing through our solar system in all of recorded human history. The first was 1I Gar Oumuamua, discovered in 2017. It was a strange, elongated object that produced unexplained acceleration as it left the solar system. An acceleration that could not be explained by gravity alone and sparked years of scientific debate, including controversial suggestions that it might be artificial in origin. The second was 2I Borisov, discovered in 2019, which was the first confirmed interstellar comet, and which behaved more like a typical comet, releasing gas and dust in expected ways. And now there is 3I Atlas III. Each one has been more revealing than the last. Each one has told us something new about the cosmos beyond our solar system that we could not have learned any other way. Scientists believe that as newer, more powerful survey telescopes come online in the years ahead, interstellar objects will be detected with increasing frequency. What was once a theoretical possibility is now a confirmed reality. The galaxy is full of these travelers. Small bodies ejected from their home planetary systems, drifting through space for millions or billions of years, occasionally wandering close enough to a star to be captured briefly in its gravitational embrace before continuing their journey outward into the dark. Each one carries the chemistry of its birthplace, the frozen record of a world we will never visit, written in ice and unlocked only by the warmth of a foreign sun. The water of 3I Atlas came from another star system. It formed around a star we cannot see, in a world we cannot reach, billions of years before any human being existed to wonder about it, and now it is drifting through our solar system, slowly evaporating into the void, broadcasting its alien chemical signature to telescopes pointed by curious, astonished, and very lucky scientists on a small blue planet circling an ordinary star in one quiet corner of the Milky Way. We did not just observe a comet, we read a message from across the galaxy. And what it said was that water, the molecule at the foundation of all life as we know it, is not a rare accident of our particular corner of the universe. It is out there, everywhere, waiting,